So all it just says at the top of the page is you can add or subtract radicals if they are what we call like radicals. So like radical just means it's got to have exactly the same thing under the square root or cube root or whatever you're working with, and then you can add those together, and we'll show you how to do that in a second with this first example. The other thing to remember, you can't add a square root and a cube root together, or you can't add a cube root and a fourth root. They have to be the same type, so they have to be exactly the same root to be considered like radicals. All right, and I promise this is not hard. This is all you have to do. So for my first question here, I have 7, and then under the square root I have x times y. And then to that, I'm adding 3 times exactly the same thing, square root of x times y. You don't change what's under the radical, you just add the two numbers, or if it was a subtraction question, subtract the two numbers in front of the square root. And so this is just 7 and 3, this would be 10, and then you do not change whatever's under the radical, that stays exactly the same. So I have 7 square roots of xy plus 3 square roots of xy, so 10 total. That's it. What about if I did 2 cube roots of x minus 2 cube roots of 5? What would you put here? Nope, can't do this, exactly. They are not like radicals. X and 5 are different, so they're not like radicals. That's as simplified as that could get. You can't add those together. What about the third one? I have, these are both cube roots, 8 cube root 9 minus a cube root of 9. 7 cube roots of 9. All right, what if I did 6 cube roots of 7 plus a cube root of 7? How many cube roots of 7 would we have? 7. Really, I put these two problems on here for you guys because sometimes if there's not an actual number written in front of the radical, that'll throw people off. So like on C, 8 minus 1 is 7, 6 plus 1, they don't have the 1 written there. Sometimes that throws people off, so that's why I wanted to put those two questions on there. Okay, if I do 7 fourth roots of 5 minus 2 fourth roots of 5. How many roots of 5? 5. So just do 7 minus 2, 5 fourth roots of 5. Do not change what's under the radical. Can I do the next question? Nope, not like radicals. They don't break down. You would want to check that real quick before you said no. But 17 and 7, neither one break down, so cannot do that one. What about 4 cube roots of 5 minus the square root of 5? No, we can't do it. No, this one's super tricky. All right, so the first one is a cube root of 5, but then the second one is a square root. So if they're different types of roots, you cannot, they're not like radicals because they don't have the same index. So this would be another one. That's as simplified as that could be in that question. Okay, and then the last one, I just want to grab my lovely, I'm going to skip one on the next one if that's what you're seeing beneath there. But if you look at this last problem in that first example, my fourth roots, neither one of those are like radicals, right? I have a fourth root of 16 and I have a fourth root of 81. But if you look on that lovely list, the fourth roots are in the fourth column there. Do you guys see I got 16 and 81 are both on that list? So these are actually both perfect fourth roots. So the fourth root of 16, it's the second number down. So the fourth root of 16 is 4. And 81 is the third number down. So the fourth root of 81 is 3. Anything you take out, if there's something already in front, which both of these terms have that, you're going to multiply them together. So that first term is really just negative 15 times 2, which is negative 30. And the second term is really just 6 times 3, which is 18. And I don't even have a radical left when I simplify it there, so it's just an actual number. So negative 30 plus 18, those are like terms. They're both plain numbers. So negative 12 would be my answer for that question. Is anybody having a question at the moment? Okay, now the rest of these, what we're going to do today, and I'm going to skip a couple of these examples just to give you guys some more time to work on your homework here. But the rest of these, as the problems initially presented to you, it does not look like they are like radicals, but the expression has a situation where you might be able to simplify what's under a square root or a cube root, and then it might create a like radical. So that's what we're going to see in this example. All right, so this one has 3 square roots of 20 minus the square root of 45, and then plus 4 roots of 80. None of those radicals are broken down, and all of them can be. So if you want to do a factor tree, feel free. If you would rather, and just find the biggest perfect square, I always think that's just a little bit faster. So if I'm looking at perfect squares, that would be that second column since I'm working with a square root. Can anybody tell me biggest perfect square that would divide into 20? 4. All right, so I'm just going to rewrite this real quick. 4 times 5. What about biggest perfect square that would divide into 45? 9. So this is 9 times 5. And then the last one, a little tricky. Biggest perfect square divides into 80. It's not 4. 16. I heard somebody say it. This is 16 times 5. Okay, now we're just going to remove any perfect squares out from underneath the radicals. So square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. If anything's in front, we'll just multiply it. That first term I got 2 times 3, so that's 6 roots of 5. The second term just has a minus sign, so just go ahead and put the 3 right after that. So the next term would be negative 3 roots of 5. The last one, when I pull out the 4, there was already a 4 in front. 4 times 4 are going to give you 16. And then that last term would be simplified 16 roots of 5. Now if I look at the problem, root 5, root 5, root 5, all 3 terms, so they are like radicals. All you have to do, don't change what's under the square root at all when you're adding or subtracting. I'm just literally doing 6 minus 3 plus 16. Add the numbers in front. This would be 19 roots of 5 as my answer. So you might need to break down a little bit the radical to be able to do the question. Okay, now I'm going to skip C, but let's do letter B. These are cube roots, so I might write in the space for the other one here. Negative 4 cube roots of 2. Can't break down 2 under a cube root. That's as small as it's going to go. It's not divisible by any perfect cubes. What about 16 under a cube root? So your perfect cubes are like your 1, 8, 27, 64. What's the biggest cube, perfect cube that would divide into 16? 8. All right, so I'm just going to rewrite that real quick as 8 times 2. And then I've got minus 9 cube roots of 54. So if I'm looking at 8, 27, 64, 125, what's the biggest number there that would divide into 54? 27. And if you're not sure, I literally just look at the list and start to do, I like do 54 divided by 8, 54 divided by 27 until I get something that might work. And if nothing works, then that just means you can't break it down. So 54 is 27 times 2. Okay, just going to remove any perfect cubes. Nothing to take out on the first term. Second term, the cube root of 8 is 2. And the last one, the cube root of 27 is 3. If something's already in front, we're going to multiply any of the perfect cubes that we removed. So first term's going to stay the same, negative 4 cube roots of 2. Second term, 7 times 2 is going to be 14 cube roots of 2. And then the last term, 9 times 3 is 27 cube roots of 2. So initially when I looked at the problem, I didn't think I could do it. But now that I've broken down each of those cube roots, they're all like radicals. They're all a cube root of 2. So I'm just going to add or subtract the numbers in front. So just do negative 4 plus 14 minus 27. And again, you do not change the radical. You just add or subtract the numbers in front. So it should be negative 17 cube roots of 2. Does anybody have any questions? Okay, let's try some fourth roots for this next problem. All right, so if you're looking at that little yellow paper, make sure you look at the fourth, oops, let me move this up a little bit. Make sure you look at the fourth column there. So initially when I look at this, I don't know how to break down any of those. They're not perfect fourths as they're written here. So can you tell me the biggest perfect fourth that would go into 32? 16. 32 is just 16 times 2. And then what about biggest perfect fourth that would divide into 162? 81. Sweet. 81 times 2. And then I'm going to do 3 fourth roots. Anybody tell me the biggest one that'll divide into 512? Oh, yep, 256 times 2, right? Good deal. Okay, now we're doing the fourth root. So sometimes these will throw people off. Actually, all three of these perfect fourths are also perfect squares. So make sure you pull out the right number. If you're doing a fourth root of 16, we're going to pull out a 2. 16 is 2 to the fourth power. Fourth root of 81 is 3. 3 to the fourth power is 81. And fourth root of 256 is 4. If something's already out there in front, we're just going to multiply it. So I've got 20 fourth roots of 2 for that first term, minus 18 fourth roots of 2 for the second term, and then plus, let's see, 12 fourth roots of 2. These all end up being like radicals, so just take the numbers in front. I'm going to do 20 minus 18 plus 12. So you got 14 fourth roots of 2 all simplified. Anybody having a question? Okay, now this other one at the very end here, these are cube roots. So make sure if you're looking at your perfect cubes, you're looking at that third column on that little piece of paper. So that first term, I've got 5 cube roots of 3. You're not going to break that down any farther. If I look at the next term, can anybody tell me biggest perfect cube that would divide into 192? 64. All right, should be 64 times 3. All right, can anybody tell me biggest perfect cube that'll divide into 375? 125. If it ends in a 5, I would check like whatever number ends in a 5 on your list that you're looking at. So this is 125 times 3. Okay, perfect cubes. I'm going to remove a 4 from the second term and a 5 from the last term. So I'm going to end up with 5 cube roots of 3 minus 16 cube roots of 3. And then minus 12 times 5 is 60. Cube roots of 3. And then I'm just grabbing my calculator. Those are all like radicals once I simplified that. So I'm doing 5 minus 16 minus 60. Should get negative 71 cube roots of 3. Do not change the radical. Just add or subtract the numbers in front if you can, if they're like radicals. Okay. On the back, I'm just going to do a couple more with you, but these two at the top here involve variables also. But that just because it has a variable doesn't mean it can't be a like radical. So I've got 3 times 225x under a square root and then plus 5 times 144x under a square root. Anybody, actually, this is kind of a tricky question. Anybody know square root of 225? It's a perfect square. I know my list doesn't go up that high. Does anybody know square root of 225? It's 15. This is actually a perfect square here. Now, the x is going to have to stay underneath, but I can actually just completely remove that number. So 3 times 15 is 45, and then left under the square root is x. And the question next to the, or the term next to this is similar. Anybody know square root of 144? 12. All right, so if you've got a 5 out in front, when you pull out that 12, no number will be left underneath. 5 times 12 will give you 60. Okay, now both of these are times the square root of x, so they're like radicals. Just take the 45 and 60, add them up. Should get 105 times the square root of x. Okay. And then let's just do this one real quick. Pretty sure we did a question that had 45 on the front. So 45 is 9 times 5. For the y squared, I'm going to leave that alone because that exponent is divisible by the index of that root. So that y squared will come out as a perfect square. And then I'm pretty sure we broke down 20 on the front too. So I'm going to rewrite that as 4 times 5. And then again, I'm going to leave that y squared alone. That's a perfect square because its exponent is divisible by the square root there. We're going to pull out, let's see, perfect squares, we're going to pull out a 3 and a y. Here we're going to pull out a 2 and a y. So simplified, that first term should be 18y times the square root of 5. That second term should be plus, whoops, added, I didn't multiply, 8y square root of 5. Can we add those together? They are like, how would you add those? Just raise your hand and tell me, what do you think the answer would be for that? There's nothing tricky to it. Yep, it says 26y. Yeah, don't change any exponents or anything like that. Just literally 18y plus 8y would be, I don't know why I just wrote 2, would be 26y. And then radical 5. Is anybody having a question? Okay, I'm going to do a couple multiplication problems. Not all of these, but some of them involve combining like radicals when you go through, but I just want to do a couple things with some multiplication here. Okay, so you can always multiply radicals as long as they're the same type. And I can't do a square root and a cube root, but I can always multiply radicals together, and you can always multiply radicals with plain numbers. These first two questions are just a little practice with a distributive property here, and we'll see if we can simplify as we go through. Some of these we will be able to, some of them we won't. So if I take square root of 7, and I'm going to multiply that by 4 plus the square root of 7, radical 7 times 4. If you take a radical times a number, the proper way to write that is just to put the number in front of the root. So that would be 4 roots of 7. And then if I multiply square root of 7 times square root of 7, if you multiply a radical by itself, you just multiply the numbers underneath. And if it's the same exact thing, it should create a perfect square. So like 7 times 7 is 49. So this would be 4 roots of 7. And then square root of 49 simplifies to be 7. I can't go any further with that because I've got a radical and then just a plain number. So this would just be my answer. Because the 7 doesn't have a radical attached to it. Does that make sense? Like, so it would be like 4x plus 7. You wouldn't add those together, right? It's the same concept. So it's like 4 radical 7s plus a 7. They're not like terms, so you can't put them together. That's a really good question. Really good question. Now, these, you have a negative outside the radical, so that's not going to affect us being able to simplify anything. Square root of 8, square root of 2 minus square root of 10. So that first term, I'm just going to have a negative in front of it. 8 times 2 is 16. That's actually going to create a perfect square for us. Negative times a negative turns into a positive. Both under a square root. Multiplication, you're going to just multiply those two numbers together, and that's going to give you 80. Now, I'm pretty sure we broke down 80 on the front. I should have gotten some better variety with my numbers here, but 80 breaks down to 16 times 5. This first term is actually a perfect square. It's just going to be negative 4. And the negative is outside the square root, so we have a real root there. Square root of 16 is 4, and it's just like, bless you, little negative 1 out in front. This guy here, just 4 would come out, so it's negative 4 plus 4 roots of 5. And you cannot put those together, just like that last question. Those are not like terms. The negative 4 doesn't have a radical attached to it, so this would just be two separate terms. Does anybody have a question so far? Okay, now, the rest of these are a little trickier, so scooch this up if I can. All right, so I have I'm going to skip letter E down there, and don't worry about that, but I'm going to do these other three with you. Now, how should I multiply 8 plus the square root of 11 times 1 minus the square root of 11? You know algebraically, like how would you go about multiplying those two? Okay, if you all like a box, you could draw a box for this too, but just double distributive properties, how I think about it, but FOIL, first outside, inside, last. And so I'm going to multiply 8 by both of these guys. 8 times 1 is just going to give you 8. Now, 8 times negative square root of 11, I'm going to have a negative there. And if it's just a plain number times a radical, you just go ahead and write the number in front of the square root. And then I'm going to have square root of 11 times both of those terms in the second set of parentheses. So square root of 11 times 1, those are both positive. So this would be plus, if you want to, you can write this, but you don't have to. I'm going to write 1 square root of 11. Or you could just write square root of 11. Now, on the end, you have one of these is positive and one of them's negative. So I should have negative. And then under the square roots, both of them are 11. So this will actually be a perfect square. It's going to be 121. All right, so I'm going to simplify this just a teeny tiny bit. In the middle here, I do have like radicals. This is negative 8 roots of 11 plus a square root of 11. So you're going to have negative 7 square roots of 11. The term on the end is a perfect square if you take the square root of 121, which is negative 11. The only other thing I could do there, I can combine the 8 and negative 11 together. So 8 minus 11 is just going to give you negative 3. I'm just going to go ahead and write that out in front. And then minus 7 roots of 11, which I cannot combine those because negative 3 is a plain number and negative 7 roots of 11 is not a like term with that. Okay, 2 more and then we'll be quiet. How do I do the next problem? I have square root of 2 minus square root of 3, and that whole thing is squared. How would you go about simplifying that? Multiply the same thing twice. Okay, don't do a distributive property on this, okay? Don't do a distributive property twice. Or don't do a distributive property to these terms. You are multiplying square root of 2 minus square root of 3 times square root of 2 minus square root of 3. The biggest mistake people make on a question like that is they'll distribute that exponent. You cannot do that if you have adding or subtracting inside the parentheses there. It has to be like a FOIL, or if you want to draw a box, you can draw a box, because if you don't, you'll totally miss out on the middle term. All right, now both of these guys are under square root, so we can simplify these. Square root of 2 times square root of 2 turns into square root of 4. Square root of 2 times negative square root of 3 would be negative square root of 6. And I'm actually going to get that same term again because I'm going to get negative square root of 3 times the square root of 2, so another negative square root of 6. And then on the end, negative times a negative turns into a positive. 3 times 3 turns into square root of 9. Okay, the first term is just a 2. The last term is just a 3. In the middle here, this is negative 1, negative 1. Those are like radicals. You have negative 2 roots of 6. Negative 1 minus 1 would be negative 2. Sorry. And then I have this 3 on the end. The only other thing I can do there, I can actually take the 2 and 3. Those are just both plain numbers. Add those together. So I would write this as 5 minus 2 roots of 6. And again, you can't do anything else there because I have 5 as a plain number. Negative 2 roots of 6 is a radical, and we can't combine those. Does anybody have a question? Okay, the very last one. I'm going to do this with you today, but we're actually going to work more with problems that look similar to this a little bit. Maybe if I can scooch this up next week. So, that very last problem, do you guys see how these are exactly the same, but one's a plus and one's a minus? All right, they have a special name, but we're going to get into that next week. But I'm just going to do exactly what we just did on the last question. I'm just going to do a FOIL, and this is going to be a special case. So, identical, one's a plus, one's a minus. All right, radical 5 times radical 5 is radical 25, right? Radical 5 times a negative radical 2 is going to be negative radical 10. Now, this is the part that's kind of cool about this. In the middle, I'm going to turn around. I get positive 2 under a square root, positive 5 under a square root, so I get plus square root of 10. These two terms right here are going to be opposites, so they're going to cancel each other out. And then on the end, one is a plus and one is a minus. So 2 times 2 is 4, but it should be minus square root of 4 because one was positive, one was negative. And the radicals are all going to cancel out here because these are both perfect squares. This is just 5. These cancel out. And then down here on the end, it would be minus 2. And put together, the final answer there is just going to be 3. Is anybody having a question? Okay, I skipped this one. You guys don't need to know how to do this. This is kind of complicated, letter E. And that goes with number 21, if you want to cross off 21 on the homework assignment for tonight. Everything else should be super similar. Just skip number 21 because I skipped that example in the notes. And so that's all I'm going to have you guys do today.